So welcome to this here LineTraceSingleByChannel video. Not a particularly sexy name, but a pretty useful result. Let's have a look what we'll be doing by the end of it. By the end of it, we will actually be getting logged out the world space location of what that there cursor's pointing at. 0 if it misses the terrain altogether for the sky, and otherwise an actual point in the world to aim at. Cool. So at the moment we're getting a unit vector out of this code, and that's cool. It tells us the world direction that is the line from the camera through that dot, but that's about as much use as a chocolate teapot when it comes to actually having a point in the world to aim at and try and hit. So what we're going to do is we're going to now line trace through that dot basically into the world and see if we hit anything visible. And the skybox, I think, out there does not count as visible, but everything else, if you can see it, you can hit it. So in the previous section in Building Escape, we did a line trace single, but I think we did it by object type. This time we're going to look at a slightly different line trace. It's going to be line trace single by channel. Now, if you don't remember what the line tracing was all about, take a look at Building Escape. There's some videos in there that talk about it in some detail. Also references you to some Unreal docs that talk about line tracing and collisions. They all work under the same kind of system, which is why it's talking about collision channels. But anyway, this is the method that we're going to use. So where in our code is that going to appear? Well, we have this getSiteRayHitLocation method, and we're saying if we can find a look direction, which we have managed to do, then we should come in, and I'll move this comment inside the if, and line trace along that look direction and see what we hit, up to some maximum range. So that's what we're going to do there. I'm going to stop logging the look direction because we don't need it anymore, and then I'm going to challenge you to write the code in here that actually goes and does that line trace and reports out where we're hitting in the world. So that's going to be a nice little challenge for you. It's mainly revision, but you're using a different method that you've never used before. So here's your challenge slide. Write get look vector hit location as a method. That method call will go in here, so I'll put it in comments, get look vector hit location, like so, and it's going to take some parameters. I'm putting it straight in a method again to keep this whole method, getSiteRayLocation, small, and so that we don't need to do the painful refactor that you saw me do before. So we're going to write a whole new method called getLookVectorHitLocation to wrap up that functionality. Make a line trace range parameter, so make a private member called line trace range, probably make it exposed to the blueprints, and make it default to say 10 kilometers, so that that's the limit of how far out it goes looking for something visible to hit. Line trace out to this distance in the look direction, trace by ECC visibility channel, basically if you can see it, you can hit it, and return true if you hit something, and set hit location as an out parameter. And if nothing's hit, return false, and log out to see what you're hitting. So that's it. Go ahead and do that. And remember, the method you're going to be using is this one here, line trace single by channel. You can find it in Unreal's docs. It's on the screen there. And I'll just pop back to the challenge slide and leave you to it. Okay, welcome back. So let's make this happen. Firstly, I'm going to write the method directly under here so I can see it, I think, so I can see what I'm calling. I want to be able to see what I'm calling its parameters all in one place. So it's a bool because I said we'd give a success result, a tank player controller, class name : get look vector hit direction, location rather. We're actually getting a location in the world here. We need an F vector according to its, well, not according to anything, but we obviously need to know the look direction. So we need to take in the look direction, and we're going to send out through these horrible out parameter things, which I still hate, but I'm willing to use, hit location. And this whole method should be const because, well, it shouldn't be changing any member variables. Wicked. So that is the signature. Given the signature, let's pop it into the header file, strip out this syntactic noise, as I call it. By the way, the reason why in a C++ file you need to qualify with the class name like this is because you can actually define multiple classes in a single .cpp file. We never do. We seem to be always using one CPP per class, and that's the Unreal way, which is why this thing becomes noise, because you only ever need it if you want. You only would really need it if you wanted multiple classes in the same CPP file. But anyway, I digress. That's the signature of what we're trying to do. And there is the outline of it. So we may as well call it straight away. So the call is going to be here. Now we're going to pass in a look direction, which we have here, and we are going to pass in a hit location as an out parameter. So we need to have that hit location ready to be set. Well, it is ready to be set because remember it came in here. So the hit location came into get site ray hit location, and it's finally going to get set there. So the look direction comes from here. It's a temporary, it's declared here. It is value assigned to it there. It gets that unit vector, remember. We pass that unit vector in here, and then we expect it to set this hit location. Hard to read, isn't it, with all these out parameters? But that's the way the cookie crumbles here in Unreal. So how does the actual method work? Well, we've done this type of thing before. We're going to need an f hit result, right, to store our hit result in. What should we call it? Let's call it something cryptic like hit result. Then we're going to need a start location. We've got to start somewhere in the world, right? It's going to be the camera position. So let's cryptically call it start location. And the way to get that, this bit may have been tricky for you, but there's lots of ways of finding this camera. But one way is to say player camera manager, and congratulations if you work this out for yourself, get camera location. Now look, by the way, if you didn't work it out for yourself, maybe you want to pause the video again here, because this is the hardest bit of the challenge, was probably finding that camera location. So if that was the only thing that was stopping you, then pause the video here and carry on. Otherwise, let's keep going. We need an end location, so let's call it end location. Now, what is the end location? Well, it's the start location plus the look direction times this range that I was talking about. Now, let me put some brackets in here now, so that you're very clear on what bonds with what. We're saying start at the start and then go out in the look direction to the range, and we're going to call it line trace range. Okay, so we don't have line trace range. We haven't declared that yet. Let's go ahead and declare it. It's going to be an edit anywhere floating U property, I believe. So yeah, U property. Edit anywhere, so the designer can set that value. It's a float because it doesn't have to be a round number of kilometers, and all these things are expecting floats anyway, and we want to do a floating point multiplication in here so that we get a floating point number out for end location. So line trace range equals 10 kilometers. So remember, it's in centimeters, this thing, this unit in Unreal. So we need to go 10, and then we need 1, 2, 3 to turn that into kilometers, and then 1, 2 more zeros to turn it into, from centimeters into meters. So that's how many noughts you need. How many noughts exactly is that? It's 3 for the kilometers, 1 for the 0, and another 2. So we have 6 noughts in total, 1,000,000 centimeters. Sounds like a lot. Okay, so that's that. Now we have this line trace range. So what do we do next? Well, I'm going to write a slightly awkward bit of code here, but I think this is the best way I can think of writing it. We're going to say if, let's pseudocode this up for a second. If line trace succeeds, and there's going to be a load of lines of line trace code, so if the line trace succeeds, then what are we going to do? Well, then we're going to set the hit location that comes in, this guy here. Let's just do it as a comment for now. And return true. If the line trace doesn't succeed, we must have got to here, in which case we return false. If it doesn't hit anything. Okay, so that's all fine. Now, the question comes, where are we actually going to do this line trace? Well, I'm going to do it right inside the if statement. Again, it's a little bit side effecty, but I need to get you used to reading code like a compiler reads code, and reading code that Unreal write in their engine, because as we go through this course, particularly in the AI part, we're going to be diving right here into the source of the engine, and we need to better understand their code. And if I teach you to make code that's all kind of wrapped up and beautified so that we don't get scared, then you won't understand engine code, and that will put you at a massive disadvantage. So I'm going to teach you to write code, as I say, in the way that you're going to see things. So what we're going to do right inside the if statement is we're going to go get the world, because that's the context in which we need to do the line tracing. Then we're going to line trace single by channel, okay? Now, what I'm going to do is I'm going to split this over several lines. So far, so good, but the line trace single by channel wants some parameters, and I'm going to take the bold step of putting them here with 2 indents, because I think that it's going to work out looking okay. So hit result, what does it want next? A start location, which we've already set up like good boys and girls, an end location, And finally, we need to know the eCollision query channel thingy. Right, so what is that? Well, there's a static available for us. If we go for eCollision channel, colon, because we're accessing a static member, ECC visibility, that tells us that I want you to go out and hit anything what is visible. And then if I leave the bracketing something like that, then to me this makes sense. The only thing we need to finally do is we need to return the hit location here. So the type that comes out of this line trace is a hit result. So the way that we get the hit location is we go the hit result, which is not in itself the vector that we want, and then we go dot and see what members it's got. And somewhere in here, we should have something about location, probably under L. There you go. Hit result dot location. Now, if we look at that, then that is actually the F vector type we're looking for. So again, another tricky bit of the challenge may have tripped you up. It's like, well, what the hell comes out of this thing? It's a hit result. That is not a vector. How do I get it from it? So that's how you do it. Wow. That's been fun, hasn't it? So let's firstly see if it works before we then have a quick recap of the code and a brief celebration. If it works. And if it doesn't work, well then there's commiserations and lots of fixing to do. Got to say something while it compiles. I could just hum. There we go, it's compiled. Let's take a look. Now, all very well, it may be working, but of course we're not logging. So the hit result is coming out of get look vector hit location. We're calling hit vector location. That's meaning that get site ray hit location should work. So we should be all the way back here now at the aim towards crosshair, and we're back to hit location. And it may even work. Let's try this. Hit location to string. Yeah, let's see if that works. So all I've done is I've said that actually we've now written all the sub-methods, all the helper methods, and we should actually be all the way up here. And the only log that we should be seeing in this entire file, let's do a search for it while it compiles, searching in the current document with case sensitivity and without regular expressions, there's one there in aim towards crosshair. There's another one in begin play, which is fine. It's fine to say whether we are or aren't possessing a tank. So, boom. Now, is this feasible, this value, this place that it's hitting? No. What we've got here is we've still got the camera location being logged out. So there's be a simple problem with the wrong variable name being passed somewhere. So let's just go find that. Let's work it all the way through and see what the problem is. So let's start from here. Aim towards crosshair, calls if get site ray hit location, which will find out what the hit location is. So there's a parameter here, which goes and gets the look direction, and then pass that into get look vector hit location. So there's hit location again. Comes in here. And look what I've done. Hit result dot location. That's all very well. That's very nice. But I never assigned that to hit location. All right. So that's the sort of thing that can happen. Now we should be in business. Let's try a recompile. I'll leave the code of this method on the screen and highlight it for you while it compiles, because that's the destination code you're looking for, and I want you to make sure you understand how it works. And you're not too put off by this weird indentation with this if statement. This could all be on one line, all of this stuff. I could have just laid that out on a single line, then that if statement would look perfectly normal, but it wouldn't be so easy to read. Now, is this feasible? So where are we in the world? So if I click on my player start point, I think it would be prudent actually in the world outliner to set that player start point to 0, 0, 0. There, lift it up off the ground enough that the tank spawns in the world. So now knowing that we're at 0, 0, 0, is it possible that that X location is 2 meters in front of us? Definitely. Is it possible now that that's 28, what is that, 28 kilometers away? Sorry, 2.8 kilometers away? Definitely. And is it possible that the Y location there is just 15 meters to my right? Absolutely. And the Z, let's say look at a mountain in the distance and then go up it and see if the Z increases. It does. And then look what happens when we get into aiming into space. We get pretty random values because we're no longer getting a successful hit location. Really, if we don't get a successful hit location, we'd probably better set hit location to something, even though we're returning false, I'd rather it was set to vector 3, F vector 0. Because I don't really want some nasty values coming out of it. So let's just do that. which means that in the instances where we don't hit anything visible, the sky, as I said, isn't considered visible, we're going to get 0, 0, 0 out of it, and a false from our method. Oops, I think my tank just fell through the floor there. There you go. So we get 0, 0, 0, which looks much tidier, and then otherwise we actually get the world space location of the thing we're aiming at. This is real progress, guys, so congratulations, and I shall see you in the next one.